In example 3, we're interested in determining I, where I is our current running through our 600 ohm resistor. Now to do such, we're going to have to reduce our circuit to the most simplified version such that we can find our current I sub s that's coming through our source, and then we can perform current division. For us to determine I sub s, we have to reduce our circuit into the most simplified version. To begin, we recognize our 150 and 600 ohm resistor exist in a series configuration. That is, Rs would be equal to 750 ohms. In doing such, we can reduce these two resistors into one. Then we'd recognize that Rs would be in parallel with our 500 ohm resistor. That allows us to calculate our equivalent resistance for our parallel configuration. That is to say, Rp would be equal to 500 times 750 ohms squared per the summation of our two resistances in our parallel configuration, or 500 plus 750 ohms, such that Rp would be equal to 300 ohms. With this, we recognize that Rp is in a series configuration with our 200 ohm resistor, such that we can solve for Is, our current flowing out of our voltage source. Is is found via Ohm's law by 40 volts per 500 ohms, which gives us a numeric value of 80 milliamps. Now we can expand our circuit back up and perform current division. In doing such, we will re-expand our circuit to where we reduced our 150 and 600 ohm resistor to our serial portion, and now perform current division on our parallel network. That is, I would be the resistance of our opposing resistor, 500 ohms, per the sum of our resistances of our resistors in our parallel configuration, 500 plus 750 ohms, times our source current, Is, which was 80 milliamps. Therefore, I would be equal to 32 milliamps.